This video is for geometry. We're going to talk about section 2.5, postulates and paragraph proofs. But before we get into that, we're going to start with a warm-up. So what you'll want to do is, I'm going to reveal this warm-up. You want to pause and then see if you can answer the questions. So you should have your notebooks out. You should be taking notes on this. I know you have a lot of notes on 2.5 already. Add these right to it. Maybe you just want a blank sheet of paper and rewrite this stuff. Or you could have your notes out and along the side, if you have blank spots within those notes, fill them in there. But here's a nice warm-up. So again, pause this now and with a partner, answer these three questions. So on the first one, is it inductive or deductive reasoning? At HHS, if you're tardy 3 times, you get a detention. Devin has been tardy to geometry 3 times, so we conclude he will get a detention. That is deductive reasoning. It uses facts. It's a fact that at HHS, if you're tardy 3 times, you get a detention. So it's not based on observations. It's not based on a pattern that's been noticed. It's based on the hardcore facts. The second one, is it valid? If you eat carrots, your eyesight is super. Karen's eyesight is super. Therefore, Karen must eat carrots. That is not valid. If you eat carrots, your eyesight is super. If then we were told that Karen eats carrots, you could conclude Karen's eyesight is super, but it doesn't work the other way around. You need to, if you have a true statement, you need to know that the hypothesis is true, and then you can say the conclusion is true. It doesn't work the other way around. And then the third one, draw a valid conclusion. Remember, this is the law of syllogism here. So if you would have said, if you come to school early, then you will turn into a genius. Remember, you cross out the conclusion of one and the hypothesis of another when they are the same and combine what's left. You could have also said, if you do extra math problems, then you'll make lots of money. After you said both of those, you could take those two statements, combine them, and say, if you come to school early, then you'll make lots of money. So the lesson on 2.5, postulates and paragraph proofs, the objective is to identify and use basic postulates about points, lines, planes, and to write paragraph proofs. Understand first what a postulate is. It's simply a statement that is accepted as true without proof. So over the hundreds and thousands of years, there are certain things that have never been proven, but there's never been a counterexample found. Those are what we call postulates. From those postulates, we can prove other things. So you should already have listed all these different postulates. Through any 2 points, there is exactly one line. So if you have 2 points, there's only one line that can go through them. A line has to contain at least 2 points. Through any 3 non-collinear points, there's exactly one plane. Non-collinear means that they're not all on the same line. So if you have 3 points that are not all collinear, then there's exactly one plane that could go through those 3 points. A plane contains at least 3 non-collinear points. So in order to have a plane, you need to have 3 or more points, and at least 3 of those points must not be collinear. If 2 points lie in a plane, then the entire line containing those points lie in that same plane. If two lines intersect, then their intersection is exactly 1 point. And if two planes intersect, then their intersection is a line. Remember, think about the ceiling and the wall. The ceiling's one plane, the wall's another. Look at where they meet. That they meet in that at that crease in the ceiling where the ceiling and the wall meet. That's a line. So then we use those uh, those postulates to determine whether statements are always, sometimes, or never true. So what you can do here is you can go through and look at the statements I have and see how you would answer them. So why don't you pause and see how you'd answer these. Alright, so if plane T contains line EF and line EF contains point G, then plane T contains point G. Well, this is always true. That's my word, always. So why is this always true? Well, if a plane contains a line, then that plane contains all the points on that line. So if that line has point G, then the plane that line is on will also contain point G. Line GH contains 3 non-collinear points. That's never true. A line can only contain collinear points. All the points on a line are collinear, so you can never have more than that. Plane A and plane B intersect in exactly 1 point. That's also never true. Planes intersect at a line. When planes intersect, their intersection is a line every time. Point N lies in plane X and point M lies in plane Z. You can draw only one line that contains both points N and M. This is always true. Why? Well, if you have 2 points, there's always just one line that can connect or contain any 2 points. If you could try to say sometimes, but that would only be no, I was just joking around about that. I was thinking if they're on the same plane and you kind of considered the same 2 different named points on top of each other on the same point, but it it says that both points are on different planes, so it's always. So here's the next thing. We're going to start with using proofs. So we're trying to prove certain things to be true. Here's the rules. We're going to turn a cat into a dog. You must start with the word cat and end with the word dog by a series of logical steps. You must change only one letter in each step. Each step must follow directly from the previous step. The word in each step must be a real word and can be found in the dictionary. And there may be more than one route to get the answers, so no one way is necessarily better. So what you need to do is try to do this. Turn the word cat into dog by the rules that I've shown. So pause and see if you can do that. So I'm sure you compared answers and are ready to see mine. There's different ways you could have done this. You have to start with cat. We're turning a cat into a dog. So the first thing I did was change the A to an O. A cot is a real word that some people sleep on. And then I changed the C to a D. A dot is a real thing. You might think of a point as a dot. And then the T to a G. Dog is what we're trying to get to. That was really fun, wasn't it? All right, so why don't you try it again? Turn math into hugs. Pause here. See what you can do. Here's just one example of what you might have done. I changed the H to an S. Mats, like we use plenty of wrestling mats throughout the year and season. Change the M to an H and you have hats. That's what people wear in school that they're not supposed to. Change the A to a U, huts. Those are small buildings, if you will, oftentimes found on beaches. Change the T to a G, and you have hugs. So now it becomes a little bit more difficult when you need to write proof using geometry concepts. Given that C is between A and B, and segment AC is congruent to segment CB, write a paragraph proof to show that C is the midpoint of AB, segment AB. So in doing this, you think of logical arguments that are going to get you from one step to the other. Write out a paragraph proof. I'm going to show my sentences kind of as steps just so that you can see the different steps a little more clearly, but you would normally just write these out in a paragraph. So first, if C is between A and B, then points A, B, and C are collinear. We know that to be true. So then if they're collinear and C is between A and B, we can say AC plus CB is AB, is equal to AB. So the lengths of those segments. And then if the segments are congruent, as it says right here, then their measures are equal. So the length of AC must equal the length of CB. From the definition of midpoint, if C is between A and B and AC equals CB, then C is the midpoint. That's a logical proof going through. Might need to pause and relook at that or watch the video again later. Now, I talked about what a postulate was, where basically it's never been proven, but over hundreds and thousands of years there's never been a counterexample found. Well, theorems come from postulates. So if we assume postulates to be true, then we can use those postulates to prove different theorems. So a theorem, once a statement has been proven, it is a theorem. Now it can be used as a reason to justify statements in other proofs. So basically, theorems have been proven, but they may use postulates to be proven. So basically, as far as you're concerned, you could take postulates and theorems and just treat them as facts. They are true, we accept them as truths, and we use them for reasons and proofs. Here's another theorem. If M is the midpoint of segment AB, then segment AM is congruent to segment MB. Remember, the midpoint is a point exactly in the middle of two other points. So now with that information, I just want to kind of reassure you here and remember, keep a positive attitude about working through proofs in geometry class. For many students, it's frustrating. We prove things in geometry for a couple of reasons, for many reasons. We don't do it because we will use it in our jobs when we grow up, although it may be useful depending on what profession you go into. I think lawyers need to use logic to prove things. We prove things in geometry because it is an exercise of logic and discipline, which are both necessary in the real world, no matter what profession you go into. Geometry is challenging and can be frustrating at times. It requires a strong discipline of mind to stick with frustrating problems, work through them logically, not give up, and write out many stepped proofs, which can be tedious at times. This discipline is needed in any field of study in school or profession. A proof is a mathematical way of showing that a statement is true. But more importantly, in proving things, we learn more about why they are true. Logic and reason are tools that are very useful in understanding the world around you and having educated views. Constructing proofs helps build your skill in using logic and reason to forge a chain of thought that can bridge the gap between two sides of a river and help you get across. So with that said, keep a positive attitude and a strong work ethic. Just try your best. These are the problems that you should have done or should be working on from section 2.5. I look forward to your questions in class.